So here are some questions based on laws of motion. A water drop is falling with constant speed, still there is no net force on it. Is it possible to have motion without net force? Actually, we can say yes or no, but here we need to explain it. I'm including explain. So, according to first law, Newton's first law, um, if a body is in the state of rest, it remains in rest. If it is moving, it will be in motion until or unless an external force is applied. So if a body is moving, it doesn't require any force to move. So actually, if it is moving with constant speed, that is, no net force is acting on it. So it is totally possible. Why water drop is falling with constant speed, that is a different concept. We will discuss about it later on. But if it is moving with constant speed, it means no net force is acting on it, and it is totally acceptable. Next, when we jump from a height to cemented floor or sand, change in momentum remains same. How? Then second part, force experienced is different. How? Which is greater? Okay, so actually, which is greater? I mean, momentum and force, we are not talking about them, but on cemented floor or on sand. So change in momentum remains same. Yes, if we jump from same height, we will gain same speed, and after reaching the floor, we will come to rest. And whatever our momentum we have gained, let us suppose 100 meter per second, it will come to 0. So change in momentum will be 0 minus 100, that is minus 100. Minus is a different thing, but change will remain same in both the cases if we jump to any of it, either cement or sand. So change in momentum remains same, no problem with that. But force is different. How? Because in cemented floor, it will take less time for us to come in the state of rest. And in the sand, it will take little more. So now we know that force is directly proportional to rate of change of momentum. Here, for cemented floor, T is less, so F will be more. And for sand, T will be more, so F will be less. Simply, you can explain it by this. You can write it in your own words, but the thing is that, and here I have explained this part also. All right, ratio between masses of two objects are 2:3. If equal forces applied to them, find ratio between their acceleration. So equal forces are applied. F equal to ma, we know F1 equal to m1a1. So upon F2 equal to m2a2. Forces are equal, that is F upon F, and mass is 2:3, a1 upon a2. Now you can solve. Okay, a ball of mass 500 gram initially at rest, initial velocity 0, kicked with the force 2 Newton. Force is 2 Newton. First you need to change it into SI units, so it will be 0.5 kg. Then okay. Change in momentum. Find change in momentum during force acted for 0.2 second. All right, so change in momentum. For change in momentum, we need velocity. Actually, velocity is required here. So directly do one thing, F equal to ma, put F equal to ma. And you can also use this mv minus mu, I mean final momentum minus initial momentum, but break it into steps. F equal to ma, from here find a, whatever comes. Then use v equal to u plus at, and then p equal to mv. It will be convenient. Last, a train having mass, I have written it randomly, so don't challenge it with the specific datas. Right, so it is just a question. 50,000 kg is moving with the speed, convert it into meter per second. Speed decreased to 30, convert it into meter per second in 30 seconds. Find initial momentum, mass into initial velocity. Final momentum, mass into final velocity. Don't use these. First convert them into meter per second, then multiply. Here also. Force required to slow down. So you can find change in momentum and then directly apply F equal to change in momentum, subtract both of them upon time taken. Or you can also do this thing, two velocities are there, time is there, you can find acceleration and then F equal to ma you can apply. So both method you have.